kunt wel plaatsnemen.
Hierbij open ik deze academische zitting waarin Marvin Martens het academisch proefschrift getiteld Adverse Outcome Pathways Coming to Life, Exploring New Ways to Support Risk Assessments in het openbaar zal verdedigen. Mag ik u verzoeken een samenvatting te geven van uw proefschrift?
Thank you, Pro-Rector. Thank you, highly esteemed opponents. Thank you, family, friends. Thank you, people online. Gracias a la familia en línea. Today I will present my work that I did as a PhD, and I will do that in Dutch. So from here I will transition to the Dutch language. Dank u wel allemaal voor hier te zijn om mijn werk te presenteren aan u. Getiteld mijn project, mijn boekje, Adverse Outcome Pathways komen tot leven, verkennen van nieuwe manieren om risicobeoordelingen te ondersteunen. Risicobeoordeling van chemicaliën, van stoffen, van materialen is overal rond ons. Denk aan het eten wat je eet, denk aan de afvalstoffen die in de lucht terechtkomen bij fabrieken of in wateren. Maar ook aan de medicatie, waar je dus kijkt naar de positieve effecten van een stof, maar er is een hele korte weg naar de negatieve effecten of de bijwerkingen van zulke dingen. Als enkele voorbeelden, denk aan bestrijdingsmiddelen, waarin is aangetoond dat dit kan leiden tot de ziekte van Parkinson. Of in de Tata Steel fabriek in Nederland in Amuiden, waar fijnstof is gekoppeld aan de longkankerontwikkeling in de regio. Zoals ik noemde, paracetamol kan vrij makkelijk leverschade veroorzaken. Als het niet optimaal gebruikt wordt en niet genoeg gereguleerd is daarom. Het gaat allemaal om de regelgeving. De vraag is, hoe testen we dit? Hoe kunnen we die informatie vergaren waardoor we die regels en aanbevelingen kunnen opstellen? Nou, in de eerste instantie gaat het veelal over dierproeven. Dat is een traditionele manier om te kijken of iets giftig of niet giftig is voor het lichaam. Dat is om na te bootsen wat er in het lichaam zou gebeuren. Maar er zitten nogal wat nadelen aan het gebruik van dierproeven voor de risicobeoordelingen van chemicaliën en dergelijke. Denk aan dat het is niet hetzelfde als de mens, dus er zijn verschillen tussen de formaat, tussen hoe ze stoffen aannemen, opnemen, verspreiden door het lichaam. Het is niet ethisch, het is duur en het is langzaam. Het kan niet bijhouden met de hoeveelheid chemicaliën die moeten worden getest voor toepassingen in producten of in voeding. Daarom is het nodig om een wissel te maken, een transitie naar alternatieve methoden. Dit zijn methoden die het complexe dierlijke model kunnen vervangen door een set of een combinatie van celkweekmodellen of andere laboratoriummethodes, ofwel methodes op de computer, simulaties. En heel die transitie vanuit de diermodellen naar de alternatieve methodes is op basis van de kennis die we hebben, de mechanismes die we begrijpen van de toxische processen, hoe een stof giftig kan zijn voor de mens. Je kan het een beetje inbeelden als dit, waar we vanuit een dierlijk model, dus een complex systeem, gaan naar alle modellen in het laboratorium. Dat we eigenlijk vanuit die foto die je links ziet, gaan overstappen naar een meer gepixeld figuur. Maar omdat we dus heel veel informatie al weten en kennen over de biologie, hoe alles in elkaar zit, de mechanismes achter de giftige stoffen, kunnen we dus terug gaan bouwen en kunnen we die meer gepixelde waarnemingen gebruiken om dus de veiligheidsregels en risicolabels te gaan figureren voor de mens of voor de natuur. Die kennis, er is heel veel kennis in de biomedische wetenschappen, die moeten we op een bepaalde manier organiseren om zo effectief mogelijk te kunnen gebruiken. Daarvoor is de Adverse Outcome Pathway een framework, een raamwerk om daar zo effectief mogelijk de informatie te structureren en dat toepasbaar te maken. Je kan het zien als het organiseren van informatie vanuit een kleine schaal naar de grote schaal. Waarbij je dus op cellulair niveau kijkt naar de interacties van stoffen en op orgaanniveau de ziektes die daaruit kunnen voorkomen. En als schema van de Adverse Outcome Pathway is dat er een startpunt is waar dus die keten, zoals een domino, zoals je het hier ziet eigenlijk, kan worden gestart. en de keten kan gaan omvallen. Als voorbeeld de ziekte van Parkinson, waar dus bestrijdingsmiddelen, dit voorbeeld ga ik trouwens vaker terugnemen als rode lijn hier, kan dus die eerste steen laten omvallen en dan een kettingreactie in start brengen. Dus we zien dat die als eindpunt, als punt wat gereguleerd wil worden, de ziekte van Parkinson. We weten dat uit de moleculaire biologie dat die bestrijdingsmiddelen de cellulaire energie verstoren en dat daartussen ergens de cellen in de hersenen afsterven, specifieke type cel. We kunnen ook de adverse outcome pathways op een andere manier beschrijven als een functie om de wetenschap te koppelen aan de regelgeving. Zoals ik zei, er zijn heel veel regelgevingen en richtlijnen om stoffen te gebruiken en toe te passen. We hebben dus aan de linkerkant hier de wetenschap die data produceert met al die alternatieve methoden. Aan de rechterkant de regelgeving. Aan de regelgevingkant zijn ze juist geïnteresseerd in het opzetten van strategieën om dus de risico's te kunnen beoordelen. En het opzetten van regels. Dus hier zien we de adverse outcome pathway als een bruggetje tussen de regelgeving en de wetenschap. Waar dus die data en kennis geïntegreerd kan worden, gecombineerd kan worden en dat gebruikt kan worden voor het opzetten van strategieën en voor regels. Als centrale database is de AOP-wiki een bron waar al die adverse outcome pathways opgeslagen worden. En dat is de focus van deel 1 van mijn thesis. Waarbij die database eigenlijk wil versterken en meer informatie aan wil toevoegen door andere informatie uit chemie, uit andere databases-types, andere type databases, daaraan te gaan koppelen en om dus analyses en methodes er automatisch mee te kunnen combineren. Maar dat is op dit moment nog niet mogelijk. Vandaar het eerste deel van mijn thesis, het databases verbinden als voornaamste thema. Ik wil AOP-wiki verbinden met het zogenoemde linked data, het web van informatie. Hier is een figuur van alle databases die er bestaan en die de specifieke technologie gebruiken om dus die informatie heel effectief met elkaar te kunnen koppelen en dus dat je heel makkelijk kan navigeren tussen informatie. Als voorbeeld heb ik hier twee voorbeelden om te beschrijven hoe we die combinatie in die links kunnen leggen. Hier zien we bijvoorbeeld twee databases waarin eentje beschrijft paracetamol, de andere beschrijft acetaminophen. Op eerste instantie lijkt dat niet hetzelfde, maar in principe is dat een synoniem ervan. En als we dan standaard identificaties gaan toepassen, dan kunnen we die link veel sterker leggen. En dat geldt dus voor alle voorbeelden in biologie. Dit is een van de meest bekende. Het andere is om binnen databases en binnen connecties van informatie de verbindingen echt duidelijk te structureren. Dus we zien hier bijvoorbeeld de twee processen die in die adverse outcome pathway waren van Parkinson, het hersencelsterfte en de ziekte van Parkinson. Als we dus willen beschrijven als we dus kunnen beschrijven op een gestructureerde manier dat de ene de oorzaak is van de andere of het gevolg, dan kunnen we dus veel meer doen met die informatie en kunnen we koppelingen leggen die we niet kunnen leggen zonder die verbindingen daartussen. Dus het resultaat van het eerste deel is dat de AOP-wiki, die database dus, meer toegankelijk is gemaakt voor mens en computer. En de AOP-wiki kan nu gekoppeld worden aan andere databronnen en dus methodes. En dat is al met al kan dit ervoor zorgen dat we meer complexe vragen kunnen stellen aan die database. Het tweede deel van mijn thesis ging over het transcriptomics data-analyse. Even kijken naar de klok. Transcriptomics, ik vat even samen. Het is een analysemethode die veel wordt gebruikt in de biomedische wetenschappen en andere wetenschappen. Om dus op grote schaal alle transcripts te meten. En een transcript kan je zien als het voorbeeld wat je aan de linkerkant ziet. We hebben een kookboek in de keuken. We maken er een kopietje uit van een van de recepten. En daar vermenigvuldigen we met voor hoeveel personen dat we koken. En dat gebruiken we dus om een maaltijd te produceren, te maken. En dat is in de cel hetzelfde. We hebben het DNA, het genoom en de RNA. Dat is dus het recept waar we kopieën van kunnen nemen. Dat is wat we kunnen meten en hoe we verschil tussen situaties kunnen waarnemen. In het laboratorium ziet dat er zo uit, waarbij we dus een bestrijdingsmiddel bijvoorbeeld, om dat toch aan vast te houden, op een celkweek loslaten. We meten daar een set van alle recepten uit, hoe die verschillen met de situatie, hoe het was zonder het bestrijdingsmiddel. En de combinatie van de die sets kunnen we zien welke processen dat daar actief zijn of niet actief. Dat is de analyse. Echter, deze methode is niet toegepast in de risicobeoordelingswereld. Er wordt heel weinig gebruik van gemaakt, terwijl het wel heel veel mechanistische waarde heeft. Vooral omdat we richting die kennisgedreven risicobeoordeling willen gaan. Daarom de plan bij deel 2 van mijn thesis was het koppelen van die transcriptomics data met het raamwerk van de adverse outcome pathway. Dus om die connectie te leggen tussen de processen die we zien in die data en de kerncomponenten van die adverse outcome pathway. Hier zie je weer die adverse outcome pathway van de ziekte van Parkinson. De tool, de database die we daarvoor gebruiken is Wikipathways. En even kort een kleine introductie daarover, omdat het ook een hoofdstuk was wat ik heb in mijn boek. Het is een database gegenereerd en wordt gevoed en gebruikt door wetenschappers. Dus het is een gemeenschap georiënteerde database, zoals een Wikipedia, zoals je het ook kent. Dus veel informatie komt erin en dat kan toegepast worden op vele manieren en kan worden gecombineerd met allerlei databases. Als grafische illustratie daarvan is dit de adverse outcome pathway van Parkinson nog een keer. Waarbij we dus die processen die we zien in die adverse outcome pathway koppelen met moleculaire pathways, moleculaire processen, waar we dus die transcriptomic data mee kunnen analyseren. Dus dat komt neer op dit, waarbij we dus hier dat bestrijdingsmiddel nog een keer koppelen aan, of ja, analyseren. We kijken daar naar welke RNA daar geactiveerd wordt in vergelijking met geen exposure, geen blootstelling. En vanuit daaruit kunnen we zien of bepaalde processen worden geactiveerd. En die kunnen ons dan wat zeggen, of kunnen een voorspelling geven of een hypothese stellen. Of er een kans is om bijvoorbeeld hier die ziekte van Parkinson te ontwikkelen. Andere toepassing van transcriptomics data en de methode waar ik aan heb gewerkt, is dus ook dat je vrij snel chemicaliën kan vergelijken. Je kan risico's identificeren, omdat we het kunnen opschalen met alle adverse outcome pathways en de complexiteit die daarbij komt. We kunnen progressie zien met de tijd of met doses. We kunnen situaties met elkaar vergelijken. En we kunnen op moleculair niveau de verbindingen tussen processen in kaart brengen. Dus samengevat, het voornaamste resultaat is dat ik de AOP-wiki meer vindbaar en toegankelijk heb gemaakt en bruikbaar. Er is een nieuwe methode gepresenteerd in mijn thesis om transcriptomic data te analyseren met het gebruik van adverse outcome pathways. En de impact daarvan is dat we dus een verhoogde toepasbaarheid of misschien nieuwe methodes hebben om transcriptomics data en adverse outcome pathways echt te gaan gebruiken voor risicobeoordeling of die te informeren. Wat dus ook als gevolg kan hebben dat de versnelde overgang is naar alternatieve methoden. En over het algemeen zorgt voor een bevordering van de veiligheid van mens en natuur. Want we zijn natuurlijk naar de hele breedte van risicobeoordeling aan het kijken. Dus het ondersteunen van risicobeoordeling als voornaamste impact op de lange termijn. En dan geef ik nu graag het woord terug aan de prorector.
Dank u wel voor uw presentatie. We gaan nu beginnen aan de oppositie. En dat betekent dat we overgaan in het Engels.
Ja.
Okay, we switch to English for the opposition. And the opposition will be opened by Professor de Kok, Professor of Population-Based Toxicogenomics at Maastricht University, and he was chair of the assessment committee.
Thank you. Dear candidate, congratulations on this marvelous piece of work. It's very timely. Also, congratulations to your supervising team. I think there is a clear need to improve the use of the AOPs and to integrate the genomics data in order to make the maximum use of it. I think that is what this is all about. But I'm not here to make just compliments. I'm here to ask some interesting questions. And where better to start than at the very beginning, which is the title. And that reads, I like provocative titles, AOPs coming to life. And that means they are dead. There's no sense in making things to life that are already living. What makes you so convinced that they are dead that you actually put it on front of your thesis?
highly esteemed opponent, thank you for this question. Yeah, adverse outcome pathways, they are not by definition that. What I meant for them, that's a short answer.
Interesting. Yeah.
The longer answer, if I can elaborate, is that in the current status, we have the adverse outcome pathways mostly as fixed text that is in this database, the AOP wiki, and is not very connective, not very interoperable, and not very structured. There's no clear way how things are described in there. So in a way, it doesn't dynamically evolve with other information. You cannot attach other pieces to it. There's no way it can interact with anything. So that's where this thesis, where I tackle this issue, makes it more alive, but that doesn't sound so nice as a title.
More alive. Okay. Okay. So that gives us some common ground, and that brings me actually to proposition number 8, and maybe one of your paronyms can read out proposition 8.
The enhanced fairness of AOPs and their integration with omics data provide regulatory agencies with more robust and transparent tools for decision making, offering a comprehensive and well-structured framework that aligns with evolving scientific understanding and regulatory needs.
Thank you. So it says integration with omics data provide regulatory agencies with more robust and transparent tools for decision making. I don't think that robustness and transparency are the main bottlenecks for the AOPs. I think robustness and transparency and the understanding of the omics data, which are much more complex, is actually what is needed. So if the AOPs have been developed as a tool to simplify complex biology, and you now suggest to add the complexity of biology in order to bring them to life, that is a dangerous risk. Should the title not have been AOPs and how to effectively kill them?
Thank you for this question. Wow, this is, I didn't expect this.
No, that's why you're here.
Well, yeah, indeed, the principle of adverse outcome pathways is to make a simplification of reality, to make the transition from the complex biology and basing risk on complex assays towards like a structured framework of information where step by step each step can be measured and combined. Here indeed we go back to the complexity. I wanted to add back the molecular data, the molecular pathways, to allow these kind of transcriptomics data analyses. Because I see a lot of value in this transcriptomics data. It can measure...
Yeah, okay, I know what it can mean. I think that we sort of agree that actually bringing to life means that you effectively want to integrate that with much more complex data that gives us better understanding in order to make better use of the AOPs.
Yeah.
Okay, and I'm happy that you also don't accept the provocative title of killing them. In view of time, I want to go on to chapter 3, and I have a lot of questions on this, but they will be addressed by also by other members of the committee. So I'd like to go to page 58, where you identify a concern that relates to the integration of omics data in AOPs, which is the difference between causal and reactive pathways. And a simple yes or no will do. Am I correct that this that the reactive pathways also involve the adaptive response? I guess that is.
Yeah, the adaptive response of cells. Yes.
So now, do you agree with me that for compound classification, the total gene expression profile induced is also giving very useful information in that sense, and even if they don't relate to the adverse outcome causally, like in previous projects that we had, like carcinogenomics predicting carcinogenicity. So do you not toss away a lot of relevant information for this very purpose that you just explained?
I do not mean to toss away the information about adaptive process. Because
okay, then I rephrase my question is, you identify it as a problem that has to be dealt with. How would you deal with that problem without discarding the information that comes from gene expression profiles that are not causally linked to the AOP, to the adverse outcome?
Yeah, first of all, we need to really understand to identify which ones are the adaptive ones and which ones are the adverse ones. Because the adaptive ones, they are dynamic, they can help the cell to overcome toxicity, and this is a threshold of balancing out that needs to be overcome for the toxicity to proceed and to tip over the next key event in these adverse outcome pathways. So it is always a balance between repairing mechanisms and
Yeah, I understand
the
it's a
damage that
balance,
comes
but
up.
my question was how you're going to handle that, because also differences in, for instance, SNPs that relate to metabolism of compounds have a clear impact on whether or not an adverse outcome occurs. And that's dose related. And you cannot discriminate between that based on the gene expression profile.
Yeah, and that is the same for the adaptive responses. Some patients with rare disease might be more susceptible to get attacked or to get vulnerable against these kind of compounds that cause a particular type of damage. Yes.
Yeah. So in that sense, we agree. But this morning, we also identified that typically these early on effects that may be reflected in this non-causal response is actually where the key to the solution is, because they predict not the general biology, which is the big downstream effect that you can measure, as compared to what makes them specific in relation to the adverse outcome.
True. Yeah, that's where individuals can differ and indeed make them more sensitive to toxicity.
But the how is still to be further explored.
How to explore further?
Yeah.
Well, first of all, in my project, I did a couple of case studies, which is just on cell lines, which is one single, genotype, one single cell type. Definitely would need to test on more types of systems to see some variety in how cells respond to and how they balance out their repair mechanisms against the toxicity mechanisms. How to actually proceed with the adaptive versus the adverse pathways.
The causal.
The causal pathways, yeah, indeed. And that's what I mean with the adverse pathways. That is that we might be trying to influence the causal pathways. We can maybe counteract a couple of these processes or genes.
Okay, so you're referring to validation experiments in that sense.
Of course.
In view of time, I thank you a lot, and I give the word back to the program.
Thank you.
Thank you, Professor de Kok. The opposition will be continued by Professor Groth, Professor of Data Science at the University of Amsterdam.
Dear candidate, I really enjoyed reading your thesis as an investigation into some of the technologies that I'm very familiar with in a very important domain. And I have a bunch of questions about those technologies and how you use them. And I want to go to chapter 3 from my colleague already mentioned. And you also kind of focused on that in your presentation, which is about this idea of database mapping, so connecting the database together. So if you go with me to page 52, you talk about this manual mapping process that you do between these key events, between molecular pathways on wiki pathways for AOP wiki. And is this really manual? So did you do this manually, like so by hand, or did you automate this in some fashion?
It was semi-automated, but there was still a manual. Highly esteemed opponent. Thank you for the question, and I will now proceed to the answer. The approach was, I would say, semi-manual. At that time, the adverse outcome pathway wiki, it was not easy to get the information from it, so I needed to extract the information on the titles and descriptions from those. And then in wiki pathways, we could already match some keywords that were overlapping, like diseases or specific pathways that would be activated. But still, we went through the list, which was at that time 200 or so. I don't recall the exact number. To see if there was actually a match, like if there is a molecular pathway that describes what is happening in those key events.
So when you say we, was it just you or was it with somebody else? And was there any room for disagreement in that mapping process?
It was not me by myself. At that time, I had an intern who worked with me on this to seek out the connection. This was really an exploratory chapter of my thesis to seek for the connections. And yeah, we had meetings together to walk through the list and to cover them. It was, I would not say it was done in parallel, but it was more of a, we shared our parts and we compared our parts. We looked at each other's parts that we filled out.
And so can you say, so you can't say anything systematically about the quality of the mapping process that you did. So it's just, you did this, or you had a beer and you said, okay, that looks interesting. Or
no, there was a strategy behind it. I mean, there was not indeed, it was a manual approach, so there's always room for a lot of interpretability and interpretations.
But you didn't calculate something like inter-annotator agreement or did a strategy like that to give us some kind of evidence of how this mapping approach would work?
No.
Okay.
And that's indeed not a great thing.
So I want to keep back on this. So in the next page on 54, you say a little bit about the mapping quality, right? So you were able to identify 523 genes across these descriptors, and you found 70%. Does that mean anything? Is that good? 70%? Could you do more?
So the main question here was how much do these two databases already connect without us making any changes or updates or doing a lot of extensive work on them. And so we were mostly interested in how much of the AOP wiki is actually already described in some way or does have already some information in Wiki Pathways. And since Wiki Pathways is a community-driven database and is not complete, it does have the majority of the main metabolic pathways and signaling pathways included. And it came down to 70%, that 70% of the genes that we found in AOP Wiki was already in Wiki Pathways without us looking into the toxicity pathways or specific pathways or processes that would be specific to particular chemicals or how other.
And this was also, again, similarly done in a manual fashion with somebody else, or?
No, this was on identifier mapping. So we parsed identifiers and used Sparkle in Wiki Pathways to extract those from.
So when you talk about alternative names or previous names, you're doing syntactic matching only?
So that came all from HGNC Gene, HCNG, from gnames.org. This has a large data output of all of the gene names, their synonyms, their previous names, and their ensemble identifiers, and so and their HGNC identifiers, among others. And that's what we use to make the mapping happen.
Okay. Thanks. So I want to move on a little bit, and I want to move maybe more of a meta question that I had when I was reading this whole thesis. Is I found it very interesting, but I'm not a toxicologist. I'm a computer scientist, and I wondered, do you have any lessons for other people doing a similar project? So did we learn anything about how to build wiki-style data sets that are kind of interoperable with RDF, or is this just something you did for the wonderful world of toxicology?
I do like the community-driven approach because it's that's what both the Wiki Pathways and the AOP Wiki are. They are communities that work together, and it's really a development in towards like how do we optimally work together to combine and structure information, and that's really something that I appreciate of these two databases. They are not the standalone.
But your thesis doesn't say anything about that. So
a little bit only, yes.
What is the little bit that it says? What lessons can I learn?
Well, that community-driven approaches, they also drive usage, and they also have some sort of self-curation when people use the resources that are community-driven. There's a lot of feedback, a lot of discussion around the pathways, about the key events. And agreed, it also introduces unreliable data, but there's the community to feed back on that or to to notice those and comment on those.
So you're saying your thesis is somewhat evidence that if I'm going to build a humanities database or a social science database, that I should do this in a community-driven fashion.
To keep as much as possible in touch with the people that will use the data and will use the information, yes, it will help you drive towards a most useful resource.
Okay, do you have time for one more question?
There were 1 minute. So
Okay,
a
1
short
minute, very
question,
quick.
a short answer.
Chapter 4, you claim that making this database in RDF and available with all these ontologies is useful, especially. I didn't see any evidence that it made it any more useful than it already was.
I have only 1 minute. This is half of my thesis. So yeah, more useful in a way that we have many more ways to interact with the data, to access the data.
But did you use it for anything other than having many more ways to interact it?
Yeah, but not for like full risk assessment applications. There's many more steps to take before we can really apply it somewhere. But I have tried a lot of case studies. I have shared the information. I've shared the resource with a lot of people that use it now, for example, to produce an interface that uses the RDF. It's a Norwegian team that does it currently. Okay. So there's people using it because it is so modular to extract the data and to link it, because we add a lot of persistent identifiers and these kind of things to the data.
Okay, thank you.
I hope that was short enough.
Thank you, Professor Groth. The opposition will be continued by Professor Legler, Professor of Toxicology at Universiteit Utrecht.
Thank you very much. Dear candidates, congratulations with this wonderful dissertation and for your contribution to the wonderful world of toxicology. I did indeed think that this was a really important piece of work, because what you're trying here is to bring some very complex understanding of biological mechanisms and using biological and physiological information into risk assessment of chemicals, into decision making, something that's not there yet. So I really appreciated the way that you structured your dissertation, and I really appreciated the way that you tried to write the dissertation in very understandable language for people who are not used to the data sciences. I also really appreciated the cover of your dissertation. It was lying on my kitchen table the other day, and my husband came home, who's working in IT, and he said, well, that guy's just like me, working behind his computer all day, but wishing he was taking the dog for a walk or out fishing. So, dear candidate, let me ask you a bit of a question regarding risk assessment. I've been working a lot the last few years on microplastics. So I noticed that you've done some work on carbon nanotubules and some nanomaterials. Well, microplastics are small, very small particles that can cause toxicity, and we think that they can cause lung toxicity. And I'm wondering, how would you guide risk assessment of microplastics using the tools that you've developed in your research?
Highly esteemed opponent, thank you for this question. Indeed, that's my dog on the cover. Thanks for noticing. To come to the question of microplastics, how to study them, indeed, I had a case study where I apply it on carbon nanotubes and compare it to asbestos as being particle-sized materials that cause lung irritation and lung cancer in the end. The tools that I create are very widely applicable. The transcriptomic data is a widely used resource to test how cells are affected by toxicants or by environmental stresses or by particles. So in that regard, the methodology will not change. The challenge is more in finding the adverse outcome pathway, the framework that is relevant for this case study. Because for chemicals, we have very clear identifiers to see which adverse outcome pathways would be activated or which molecular initiating events are described for these kind of chemicals. For plastics and for nanomaterials, this is not as clear because it's more physical interaction, and there's other ways that these materials cause effects. I have the impression that the AOP Wiki is going more towards also other applicability domains. For example, we also looked at into it for immunology-related adversities with COVID-19 pandemic. And it actually works if we know what to look for and how to structure the data. And also there, if we have the transcriptomics data, we can use that data on the same type of adverse outcome pathway networks with the molecular pathways involved. For the microplastics, I'm not familiar. I didn't go into that specific field so far. But I can imagine that for the molecular effects, they would be more unique when compared to chemicals. But cellular responses later on will probably converge with what is already known for other stressors or nanomaterials and such.
So what kind of additional experiments would you then like to see?
Well, first to test what kind of molecular effects, what kind of molecular interactors these microplastics have with the cells, to understand what happens there, to mechanistically describe how they interact, why they interact, and what kind of response this causes in cells or in organs, to structure this adverse outcome pathway framework. And then when we extend that to the molecular data, see if we already have some pathways that are relevant that are for the nanomaterial toxicity, because we have those already as well, or model them based on what we know from literature, from databases, or from data directly when we see that there's a particular pattern.
Do you think we might be able to predict their risk without using any animal experiments?
Never without animal experiments at all. I think it's a transition that is not going towards zero, but towards at least as possible, or as few as possible, sorry. So I see that some in vitro assay can kind of be a first barrier to see whether something can be toxic or interacts with the cell in a dangerous way, in a toxic way. And then that's not necessary to go towards the animal. But I don't think ever that, well, maybe not in the short term at least, that the animal models can be completely ignored and pushed off the table. That's a long path towards that.
So what if we did some experiments in humans, or we got some data from humans rather than going to the animal experiments? I mean, this is a case of a class of contaminants where we don't have very much animal data, and maybe this is our first opportunity not to use animals, but to use a different approach.
And what kind of contaminants, sorry?
So contaminants, the microplastics are a complex group of contaminants that are both particles, but particles full of all sorts of chemicals as well. There have been very few animal studies done. I really would like to avoid a future where we have to test them in animals. Isn't there anything we could learn from human studies with microplastics that would allow us not to have to do animal studies?
Yeah, if we have data on human biomonitoring or epidemiological data or data on populations that have been exposed, that have it in their system, or samples from patients, we can learn about what's happening. But the risk assessment is also for new materials, for things that probably have not been produced or have not been applied yet. So for new materials, I don't see a way to avoid the the animal testing right away, because we cannot just expose humans to what we're testing for.
Thank you. May I ask another question? Yeah. I actually, I also was interested in Proposition 8. You don't have to read it again, but especially about fairness, and I'm learning a lot about fairness thanks to the Virtual Human Platform for Safety Assessment Project and the collaboration with your team. I wonder about fairness, and do we actually have an example as of yet of the integration of AOPs and omics data that could be used for decision making? Is there actually any sort of proof of principle yet?
Related to the fairness?
Yeah.
Well, adverse outcome pathways have definitely had some use cases already. Most notably is the skin sensitization adverse outcome pathway, where cosmetics industries apply it for assessing whether a cosmetic ingredient would cause skin irritation. That's the most well-known example of how adverse outcome pathways are used. Having it as like whether the fairness of adverse outcome pathways makes the process better or not, I don't think there's a real live application or proof principle of that yet. Besides that, we can very clearly describe how and where the data comes from. It's really a transition from the text-based description that we have towards understanding where it comes from, who produced it, where it came, like all of the metadata that comes with the generation and the information that is part of the AOPs.
What do you think would happen if every single new piece of data that was produced in a fair way? What would happen? What would be possible?
That would allow us to make these connections between data and knowledge and the adverse outcome pathway wiki it would facilitate this a lot. We can probably also add quantification details on the key event relationships, for example, if we have data that we can just extract from a data source that describes this relationship.
I just wonder why people are not doing that more, but maybe I should give the microphone back to the chair. Thank you so much, candidate.
Thank you.
Yeah, thank you. Yeah, because of time, we have to continue. The next opponent is Dr. T.L.J, Assistant Professor of Data Science at the Institute of Data Science at Maastricht University.
Thank you for the presentation. And I really enjoyed reading your thesis. I really appreciate that. So my first question is regarding the enrichment score that you introduced in Chapter 7. Do you compare with another scoring mechanism? And if not, do you consider also if there is a highly connected entities in the network, how this enrichment scoring will behave?
Highly esteemed opponent, thank you for this question. I use indeed the enrichment score as being a common way to calculate whether a set of genes is overrepresented in a particular situation. In our case, it's for chemical exposure toxicity. And I don't compare it to other statistical methods. This is indeed very much necessary because, for example, in pathway analysis, we have overrepresentation types analysis as well, in gene ontology kind of analysis approaches. But indeed, in the chapter that is there, which is a preprint and not published yet, I didn't compare yet to other statistical methods. Also, I agree that taking into account the connectivity or the specific role, like level, or how do you call it, ranking the genes in a particular way, how they are influencing or how they are relevant to the process, would give some extra credibility to the analysis. It would add some extra understanding about what the data is about, how strong that the most important genes also give the most effect to the outcome. But that's something that is in the pipeline because I want to extend this and add more case studies to the list. And that's also what is going to happen in the upcoming years, together with the gene co-expression networks that University Leiden is producing. But that's not yet happened, indeed.
So the second question is about you worked on wiki pathways, and this is created data. We know that there might be errors with this created data. Do you basically apply any automated mechanism to check the quality of this data?
Thank you for the question. This is indeed an issue of the community-generated or community-curated pathway database. I myself are part of the curation team that goes over the changes that happen, and we are a big team that go every week. There's one person involved in there. My colleagues do a lot of curation, specifically Egon and Denise, who are here. They do a lot of curation on the information that's in there, more on an automated way, performing queries to find where things are irregular. But for the actual pathways themselves, there's the curation, the weekly curation effort that is happening. I agree, it's not the same as other databases as Reactome or KEGG, where there's a fixed position where people curate the information that's in there. But we're getting close, and the data keeps getting updated just as our knowledge of biology keeps getting updated.
So regarding the fairness, you mentioned that you try to achieve high fairness, but we know that high-dimensional data like omics cannot be easily transformed to RDF. What kind of strategy would you apply to make it more fair, this data more fair?
The omics data.
Yes.
Well, fair is in a lot of different ways. I hear something going on. I don't think that we should model data or the molecular data into RDF, for example, which I do with the information. But at least having things like the metadata and clear descriptions of what the data is about, what it describes, where it came from, how it is produced, and by who. All these kind of metadata will help us understand the data and also trust the data. And that will be an important thing to achieve, where we can be certain about where the data comes from and how we can use it and what we can learn and how we can analyze this data.
I have last question, which is regarding when you define the mapping, I saw that you use close vocabulary, especially close exact match. Have you considered using a more expressive language like OWL? And what would be the advantage of using this?
So indeed, OWL is a way to make connections more official, more. I'm most of a user of the ontologies and consistent vocabularies, and indeed having an ontology like OWL to describe relationships would allow for more ways to find out the connections between things, where the consistent vocabulary is a tag that we add to it to describe something. So we could, using OWL and these other and other more ontological correct annotations would allow us to transverse more between data and make more connections. But that's something that I didn't apply. It's also where my previous studies limited me in my understanding of systems biology and data integration, where I'm most of a user that learns on the fly. But it's definitely a way to improve this kind of iterations of information.
Okay, thank you very much.
Thank you very much. The opposition will be continued by Professor Mortensen, Professor of Computational Biology at the Environmental Protection Agency in the United States.
Thank you, Madam Protractor. Thank you for your dissertation. I enjoyed it very much. I think you've probably answered part of this question, but I will start again. So in chapter 7 of your dissertation, you use transcriptomic data to build AOP networks, but you did not specifically incorporate this content into an RDF framework. So is there a limitation of the framework that you can describe for us and explain how you would best incorporate transcriptomic data or other similar data types into semantic annotation?
Hi, Leestem, the opponent. Thank you for the question. Indeed, in chapter 7, I don't apply RDF or anything on semantic web whatsoever. And that's mostly because I was interested in the method of analyzing the transcriptomic data, where I focused on a couple of case studies of liver steatosis and mitochondrial inhibition. In practice, we can make the connection between the two databases using Sparkle, using RDF, because the models that are created to perform the analysis, the molecular adverse outcome pathways, they are in wiki pathways, and they are also therefore queryable through the Sparkle endpoint. And since they are annotated with identifiers for the pathways and for the key events that are in AOP Wiki, this connection can easily be made, as well as all of the genomic components, the genes and the proteins that are part of those. I applied it in other case studies where I did more automated in a Jupyter notebook, the construction of this molecular AOP. But indeed, in this chapter, I went with the user interface as as I focused on the method mostly in compared to the automation of things.
Thank you, candidate. I have one more question. You have clearly made a substantive contribution with your dissertation. So what, if anything, would you specifically change or modify, possibly extend, should you be able to redo your research at this point?
Most likely, something that I see is a major disadvantage of the adverse outcome pathway if we want to analyze transcriptomics data is that we have a very hard time connecting genes to it, connecting molecular information to it. It's of course a part of what adverse outcome pathways are meant for, to simplify it. But for our mechanistic understanding and our specific data that we want to analyze here and apply, we need those molecular description. And that's something where I see that processes like using ontologies more efficiently and more structured data formatting in the AOP wiki would help us to make connections and make data and other knowledge connect to the adverse outcome pathway. And that's something that I would have focused more on when I was creating the RDF of the AOP wiki, because currently, as you saw, it was only scratched the surface of the genomic or the gene annotations that was done in this. But I would have expanded that much more to be more, well, basically to clarify more these connections and to make them more useful for molecular analyses.
Okay, thank you.
Thank you, Professor Mortensen. Then we come to the last opponent. That is Professor Vinke, Professor of Toxicology at the Vrije Universiteit Brussels.
Oh, yeah. Thank you, Chair. So, congratulations, dear candidate. I really enjoyed reading your thesis, but especially the presentation today, which was really clear, I think, also for people in the audience. So, congratulations on this. As your last opponent, I'm going to play a bit the devil's advocate here. Actually, what you claim in the thesis, which I can understand to some extent, is that you would, use transcriptomics data to either optimize or develop an AOP. Now, that would work pretty well for simple AOPs, like the low-hanging fruits, like, steatosis, which is pretty simple from the toxicological and mechanistic point of view. But how would you will be dealing with, the more complex AOPs, AOP networks that really have, like, feedback loops, homeostatic adaptations? So we know in those cases that transcriptomics as a standalone, identifier doesn't work really well. So how to deal with this and how could you overcome this?
Highly esteemed opponent, thank you for this question, relevant as question as well. Indeed, that's also something that I discussed within that last chapter, the chapter 7, where I have the two case studies. One of them is the liver steatosis, which is very much well described with molecular signaling pathways that we understand and are very that we know that exist. The other case study, the mitochondrial inhibition, is one of those less straightforward adverse outcome pathways where there's probably a lot of more feedback happening and other processes involved when compared to this signaling pathway in the steatosis. So that's where I think that the transcriptomics would be more applicable in certain situations than in others. That the domain of applicability of this type of method is in pathways and adverse outcome pathways where we exactly understand the mechanisms behind it. Because indeed we have feedback loops and we have other interactions that we don't have described in the AOP wiki.
Sorry to interrupt, but what would be your practical recommendation then? Just to drop transcriptomics for those complex AOPs or to substitute by something else, or?
I think it can still learn us a lot of information about the toxicology, so I would not drop it per se. But indeed, it will never go alone. It will always stay as a kind of hypothesis generation. The outcomes that are from the transcriptomics data would need to be validated, or other methods applied to measure the key events that it suggests to be affected in a way. Transcriptomics data it provides only a statistic whether some process is being updated or like being active or maybe inhibited. But indeed, in those complex adverse outcome pathways, we would need to validate whether this is actually happening or not in the terms of cellular process, cellular levels of energy, or cellular level of particular stress that is not so specific on the molecular level.
Okay. Needs to be considered with caution a bit then.
Yes, and that's also how I discuss it in the
Exactly. So, in your introduction, you bring up the Bradford-Hill criteria, which is really important, especially if you want to comply with OECD criteria. So my question to you is, can you elaborate on these criteria? And the second question with that is, would you also see a way to leave this over to a computer to actually assess a newly postulated AOP according to the Bradford-Hill criteria? Would you be fully confident?
I think indeed the Bradford-Hill criteria are to assess whether there's a causal relationship between entities. And there's the modified set that is applicable for the adverse outcome pathways for the key event relationships. Whether the key events are essential, like whether the domino actually tips over the next one, or if there's something not, like if it's redundant. It's mostly based on evidence that's from literature. That's how it's currently stated in AOP Wiki. And unless we have systematic approaches to extract all of the information that's from literature, I don't see a very simple way to automate the criteria. But at least we can, based on the literature and the new like AI models that to read text, to capture text, and to get information from it, can definitely help out to give us some indication of how evident is this relationship between this and that.
And what about AOP development as such? Would you feel fully confident to leave this fully over to a machine, so we don't need human beings for that anymore? No human expertise?
Well, never fully. I mean, I don't think that anyone ever would say fully leave it over to the computer to say if we're safe against this particular compound. But they can be very helpful to, like I said, generate hypotheses, for example, or give us a direction of where it sees that literature describes things. So it's a tool to use, but there's always still the human that needs to validate or approve.
Exactly, yeah. So I have very much appreciated the part on impact, because I think this is important. You need to be aware about the impact. But a way, if you're working in the AOP field, a way to really trigger impact is to get your AOP, whether you manually developed it or by means of a computer, to get it endorsed by the OECD. Are you familiar with that process? Have you, yeah?
Yeah, I have developed a couple of adverse outcome pathways in the AOP Wiki, which have not undergone review by the OECD or the ACMAST yet. I think some key events that were part of my AOPs are, but that's not something that I pursued. I'm not an expert in any of the toxicological fields or any of the organ systems by heart. Like I only produced some backbones where I hope that the community picks it up. They are open for adoption in the wiki. Indeed, it would be optimal if all of the adverse outcome pathways are reviewed and if there's feedback given on them to improve, extend them, or complete them. But
this is actually what happened. So I went through it and I bailed out halfway because it was, I had 70 reviewers. Yeah. So, I mean, this could be a field where you also could, basically have it facilitated by means of any automated way. And just two remaining questions, small ones, if we still have time. So you focus on, or you emphasize the importance of semantic ontologies. I fully agree with this. But I think it also comes down to, appropriately defining terminology. And in this respect, I was a bit confused throughout your thesis. I think you actually mix up mode and mechanism of action. Can you explain what the difference is, or is this the same for you, or how would you see this?
I indeed intermix them. To me, since I was not here in the time of the mode of action being applied as the predecessor of the adverse outcome pathway, which is chemical specific, and also describing it in a similar way of key events, the mechanism of action is for me also the molecular processes that are underlying these kind of key events. For me, they are fairly similar because they are chemical specific and they are describing the molecular process for me. But then I agree that the mode of action is something that is more upper level, just like the adverse outcome pathways are, where the mechanism of action is more on the molecular level.
Thank you.
Marvin Martens, de gelegenheid voor het verdedigen van uw proefschrift is voorbij. De promotiecommissie zal zich nu voor beraad terugtrekken. Ik verzoek u en uw gezelschap onze terugkomst en de uitslag van dit beraad in deze zaal af te wachten.
Dank u wel.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. All your time, 'cause I'll go the extra mile. Long road to the south side, 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Get the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. Even though these nights seem long, I know that I am never on my own. Know you won the battle once you've grown. South side, 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. Long road to the south side, 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. Can't fly by now, don't wait. waste all your time, 'cause I'll go the extra mile.
Jij moet hem aanpakken.
Ja, dan aanpassen. Eerst kijken.
Marvin Martens, de commissie hier aanwezig heeft zich beraden over de kwaliteit van uw proefschrift en de wijze waarop u dat proefschrift heeft verdedigd. Op grond van haar positief oordeel en gelet op de examens die u vroeger heeft afgelegd, heeft ze besloten u het gevraagde doctoraat toe te kennen. De hoogleraar, professor Evelo, is gemachtigd u op de gebruikelijke wijze met deze waardigheid te bekleden. Het woord is aan uw promotor.
Belooft u dat u altijd volgens de beginselen van wetenschappelijke integriteit te werk zult gaan, eerlijk en zorgvuldig, transparant, onafhankelijk en verantwoordelijk?
Ja, dat beloof ik.
Mooi. Krachtens de bevoegdheid ons door de wet toegekend, volgens het besluit van de commissie hier tegenwoordig, verklaar ik hierbij u, Marvin Theodor Leonardus Johannes Martens, tot dokter te bevorderen en u alle rechten te verlenen die daarvoor volgens de wet en gewoontes zijn verbonden. Ten bewijze hiervan overhandig ik u nu de bul, door de rector, secretaris en overige leden van de promotiecommissie ondertekend en met het grootzegel van de universiteit bevestigd. Beste Marvin, Dr. Martens, ik ben altijd blij om je toch als eerste te mogen feliciteren, ook al zal Egon zo dadelijk de laudatio houden. Ik ben eigenlijk hartstikke trots op hoe je het gedaan hebt, dus ik hoef daar verder niet heel veel aan toe te voegen. Egon, ga je gang.
Dank je.
Beste Marvin, Dr. Martens, gefeliciteerd. Het is een groot plezier om je te kunnen hebben begeleiden. En ik heb wat dingen opgezocht waarmee ik wil karakteriseren van hoe ik je heb leren kennen als onderzoeker en als zelfstandig onderzoeker. We beginnen even met terug te gaan naar 2016, een paar maanden voor de sollicitatie. En ik zal een cascade van dingen noemen die heel mooi voor mij laten zien van wie jij bent als onderzoeker. Je kwam bij mij met een e-mailtje van: ik heb een groot interesse om bioinformatica in te gaan. Het was niet je originele achtergrond, maar je zag daar duidelijk hoe de bioinformatica een belangrijk onderdeel gaat zijn van wetenschap. Ik had net een sollicitatie openstaan. Overigens op een heel ander project dan wat je uiteindelijk gedaan hebt. En je hebt erop gesolliciteerd. En een onderdeel daarvan was een vrij uitdagende assessment. En een van de dingen die we daar tegenkwamen is van hoe je daarmee omging. En waar ik heel erg van onder de indruk was, en wat de reden was waarom ik je met heel veel plezier op gesprek wil hebben, is het volgende. Je gaf bijvoorbeeld aan dat je het erg stressvol vond. En dat je eigenlijk niet zo heel erg gelukkig was met dat krappe uur wat ik je gaf om opdrachten uit te voeren. En dat was voor mij juist het teken om te zeggen van ja, dat is een interessant iemand. Om de volgende redenen. Je durft je mening te geven. En je durft het aan te gaan, een wetenschappelijke discussie, op dat moment al. En dat vond ik verschrikkelijk mooi. Het aantal vragen wat je goed had was schrikbarend laag, maar nog steeds beter dan eigenlijk alle anderen. Ongeveer 25% van alle vragen, de rest was leeg. En op 7 maart, had je het HR-gesprek en je contract gaat volgens mij, 2017, het contract ging volgens mij formeel uiteindelijk met terugwerkende kracht vanaf 1 maart in. Dus dat is weer even geleden. En de rest is geschiedenis, ja, min of meer. Er zijn een paar andere dingen die ik wil aangeven. Een van de dingen die, denk ik, mooi aangeeft van wie je bent, is dat je een verhaal kan geven, dat je argumenten kan geven, dat je de diepte in durft te gaan, wat we denk ik vandaag ook een beetje zagen. En één uniek ding was, wat ik nog nooit eerder meegemaakt had. Je stond er net als jonge PhD in Egmond aan Zee op een EU-Toxrisk meeting. Je had een presentatie gegeven van het idee van waar jullie mee bezig waren rond het verzamelen van AOP's. En op het eind van je praatje kreeg je een staande ovatie. Nou, ik denk dat dat een heel mooi voorspellend aspect was van jouw PhD. En als ik kijk naar het hoeveelheid wetenschappelijke output nu, is deze thesis ook maar een onderdeel van alles wat je al bereikt hebt. Ook daar gefeliciteerd mee. Mijn punt daar ook is van, tweede punt, je opent deuren. Want het impact werd al even een beetje genoemd van jouw werk, maar je schroomt er ook niet voor om dat te gebruiken en jouw kennis te delen met andere projecten. En dit opent deuren. Soms opent ook deuren die eigenlijk beter gesloten kunnen blijven. Maar een hele mooie eigenschap, want dit is ook waar wetenschap over gaat. Nadeel daarvan alleen is dat het alleen een beetje langer duurde dan een PhD. Maar ik zie dit echt absoluut niet als iets wat tekort doet aan wat dit werk heeft bij elkaar gebracht. Een ander derde punt waar voor mij je professionaliteit en je compassionateness, je medeleven bij komt kijken, is hoe je met interns, met studenten die stage liepen, bent omgegaan. En ik kan me één student met name herinneren die speciale behoeftes had. En dat was echt iets waar je echt je best voor deed om dat mogelijk te maken. En het is ons samen niet gelukt. Maar het heeft niet aan jouw inleven gelegen. Een prachtige eigenschap ook. En het laatste wat ik wilde noemen is eigenlijk iets anders. We noemden die open deuren al. En het was 2020, de pandemic. En je had een goede reden om naar de andere kant van de wereld niet verhuizen, maar tijdelijk te verhuizen. Naar de andere kant van de wereld te gaan, naar Ecuador. En daar hebben we het over gehad, want je twijfelde, want ja, de pandemic was net begonnen. We wisten niet waar het heen ging. En er was gewoon het risico dat je daar vast kwam te zitten. En ja, dat was ook. Je kwam daar vast te zitten. Een terugkerend probleem. En dit hier ook liet je weer zien van hoe betrokken jij bent bij het doen van onderzoek en het geven van onderwijs. En als ik me niet vergis, stond jij op om 3 uur midden in de nacht om studenten onderwijs te geven. Vanuit Ecuador hier in Nederland. Die betrokkenheid, dat samenspelen, dat bijdragen aan andere dingen, jouw jarenlange bijdrage aan Wiki Pathways door het omhoog houden van Sparkle Endpoint. Die dingen bij elkaar geven prachtig aan wie jij bent. En ik vind het prachtig en het is daarom ook echt een enorme eer geweest om jou te hebben kunnen begeleiden. Dus nogmaals, heel erg congratulations. En daarmee wil ik het woord teruggeven aan madame prorector.
Dank u wel. Dr. Martens, ook namens de Universiteit Maastricht wil ik u van harte feliciteren met de behaalde dokterstitel. Een mooie prestatie. Uiteraard wil ik ook familie, vrienden en collega's in deze felicitaties betrekken. Ik wil ook de promotoren feliciteren, professor Evelo en dokter Willighagen, met deze mooie afronding van een toch altijd een intensief traject. Ik zou de leden van de promotiecommissie willen bedanken voor hun aanwezigheid. Met name de leden van de promotiecommissie van buiten Maastricht. Dat zijn er een heleboel dit keer. Professor Groth, Professor Leekler, Professor Mortensen and Professor Vinke, thank you very much for being here and taking the time to come to this ceremony. Dr. Martens, ik kan u vertellen dat de promotiecommissie heel tevreden was over de manier waarop u uw proefschrift heeft verdedigd. Vol vertrouwen, dat was heel duidelijk. U weet waar u het over hebt en dat is altijd mooi om dat te zien. Ik hoop dat u ook tevreden bent over de manier waarop het gegaan is. Ja, het duurt vaak eventjes voordat dat bezonken is, maar ik denk dat u heel tevreden kan zijn. En ik wens u heel veel succes met uw verdere carrière. Voorlopig heb ik begrepen nog bij de Universiteit Maastricht. Veel succes daarmee. Dan is het nu tijd om te ontspannen. Dus ik sluit deze academische sessie. En dan volgen wij u naar de trap om daar nog een paar foto's te maken. En dan daarna zien we de aanwezigen hier in de refter voor een drankje en een hapje misschien. Denk ik. Dank u wel.
Dank je.
Recording stopped.